Lesson number 3 on variation, we are going to look at joint variation. So these are the concepts for joint variation. It multiplies two relationships of a variable. Let's dive into an example. If v varies jointly as h and as the square of r, you can see that v is related to two variables here. So this end means we are going to multiply. So part A, write down equation connecting v, r, h and a constant c. B, find c if v is equals to 440 and r is equals to 2 and h is equals to 35. So on part A here, we must leave our answer with a constant. So I am not going to find the value of a constant here, and the constant is specific, must use c, don't use k. Then v varies jointly h and square of r, which is r squared. Therefore we put our constant, which is c. C is a constant here, so hr squared is from multiplying h times r squared. So this will be our answer for part A. For part B, we then substitute the values v for 440 and h is 35, r is 2, but r is squared now. So 35 times 4, this becomes 140. We divide by 140 both sides. So this will give us 22/7, which is 3 and a 7th. So this is the value of C. So this was tested in June 2016. Another example, it is given that x varies directly as y and inversely as the square of z. X is equals to 15 when y is equals to 27 and z is equals to 2. Find the value of z when x is equals to 30 and y is equals to 294. This was a bit challenging, but let's attempt to answer this as easily as possible. So the first step is to find the relationship between the variables, these three variables x, y and z. So our proportion sign, y varies jointly, x varies jointly as y and square of z, and inversely as square of z. So this is an inverse variation, this is a direct variation. So we multiply. So this is our relationship. Then we remove the variation sign and put a constant. So our constant goes on the numerator since it will multiply the numerator. Now we want to find the value of k using the values given. We are given that x is equals to 15, y is equals to 27, z is equals to 2. All our variables must have values to find the value of k. So let's substitute. So this will be 4, this will be 27, this will be 15. Then we multiply by 4/27 both sides to find the value of k. So 4 times 15 here, it will be 60/27, or we can divide by 3. This is 5, this is 9. So our final answer here, k is equals to 20/9. So this is the value of k. Next step is to find the value of z. So let's write the relationship, the equation. So the equation here, this is the value of k. So it's 20/9y over z squared. Or you can make it a mixed fraction, 2 and 2/9 y over z squared. Then let's substitute values to find the value of z. So the first step is to make z the subject of the formula. So z squared will swap with x here. Therefore let's substitute 294 for y, then 30 for x. Therefore, since this is paper 2, let's punch this into a calculator. you can see that this will give you 21/7/9. Make sure you are using the remainder function here so that your answers will be easy to read for you, or you will be comfortable when dealing with these numbers. So it's 21/7/9. Then find the square root of this. Just put a square root on your calculator. So this will give you z is equals to 4/2/3, or 4,7 to 2 significant figures, or 4,67 to 3 significant figures. So that's how we can calculate the value of z. So this marks the end of our lesson. Few things to do, an exercise.